Alright, Naofal here, and today we have a complex hydrodynamic problem to solve. And I will guide you through it and teach you how to solve this problem. Okay, so here's the problem. A rectangular open channel with a width of b equals 3 meters carries unsteady shallow water flow at time t equals 0. So the time interval is 0. A dam is then breached, releasing large volume of water previously held at uniform depth, 4 meters, over dry bed. Using, what was this again? Using shallow water equations and dam break theory, calculate depth hxt of water as a function of time t and distance x going downstream. Okay, so the very first step to solving this problem is to understand the setup. So we have a dam at x equals 0, correct? Now, initially, zero will be greater than x. Since the water is at rest, let's write this down. Zero. What was it again? 4. So that x is gonna be less greater than 0, because the water was at rest with a depth of 4 meters. Now, what do we want to correct? Now for x to be greater than 0, so I can dry bed h equals 0. H must equal 0 for x to be greater than 0. Yeah, hopefully I'm explaining this properly. Anyway, oh shoot, wait, I should actually, okay, that helps you understand better, hopefully. At t equals 0, the dam is removed. So then water is going to rush rightward. Pretty sure it's rightward. Water is going to rush rightward. So now that we've hopefully understood and assessed the setup for what we're trying to solve, at this point, we should be using the shallow water equations to, well, get it going. Okay, so we're going to use fluid continuity equation. Focus camera, there we go. Yeah, this is horrible. I need a better camera, bro. Okay, change in, what is that displacement? Change in H U. Okay. Equals 0. We all agree that if we use fluid continuity, mass conservation for this, it equals 0, right? Now let's use momentum equation. I apologize if I'm not explaining this correctly. I literally just learned, well, I didn't even fully learn how to solve this physics hydrodynamics Olympiad equation yet, but I just understood how to do this an hour ago, so I apologize if I'm not good at explaining. Alright. So what we need, it's really hard to write and hold a camera at the same time. Equals U. Is that correct? For any experts out there, tell me in the comments if I'm doing this correct or not. What else would I need? Oh, right. H. I feel like I'm missing an important detail. Whatever. So, and then when we use the momentum equation, we're going to get 0, correct? Both of these equal to 0. Oh, right. And then step 3. My bad, damn it. I need like a... Alright. For step 3, we're going to need a self-similar variable. I don't know if you've learned what that is. I haven't learned what that is. I am just going through my notes for this self-similar variable because I don't know what that is yet. I did not learn that yet. Okay, so let's assume the solution is a self-similar. Let's assume the solution is self-similar, right? If it was self-similar, it would depend on a ratio. And in my notes, it's saying that ratio is xi, I don't know how to pronounce it, equals x over t. That would be the precise ratio we would need for the solution. So then, in that case, let's propose H equals, damn it, x, that does not look like an x, xt equals h, oh shoot, alright, h with x over t, damn it, I did not master hydrodynamics at all, just raw dogging this lesson. Okay. Alright. And then using this poorly written formula, let the ratio we talked about, damn it, not a y. Okay, let the ratio we talked about be the ratio and rewrite it using partial derivative. Rewrite it in partial derivative using the chain rule. Sorry, I got my words mixed up there. Okay. So if we use partial derivative and if we rewrite in partial derivative using the chain rule, it would be, oh yeah, this would be, if we did this to this, it would be this. Just gonna take a while to write. I don't even know if I'm gonna write it correctly. I'm just raw dogging it. Shit. Alright, tell me if I'm doing this right in the comments, people. If not, I'll fix my mistakes. Equals to xi or xi times, I hate putting the little dot there for times. I've always hated doing that my entire life. Anyway, derivative of xi with respect to t equals negative x over t squared. Yeah, don't ask me about this. I cannot answer fully since I am not a professional. I'm just teaching what I can teach. Equals minus h. Okay, this, using the chain rule, we rewrite it partial derivative form. Using chain rule, we rewrite this. It turns into this. So then for next step, I'm basically going to tell you that all of this is too complex. We're going to use something called the Ritter rules. Ritter formula or something? I don't know, something called Ritter. And I unfortunately do not have enough time for that today. So I will do that the next time, if there is a next time.